Hi, Tile at Inner Fidelity here. Today we're going to talk about a very cool product. This is a Bottlehead crack. This is a do-it-yourself kit that you can buy from Bottlehead. This is a output transformerless tube headphone amplifier that you can make yourself, and costs about $249. And it's really a terrific little amp. We'll go into the sound of it later on in the video, but right now I'm going to show you what it looks like on the inside, and you can go to the Inner Fidelity website to see the entire article. And so this is he calls it gravity mounted. Basically the entire amp is built on this aluminum laser cut chassis, and it comes with a wooden case that goes around it like this, and you can simply pick it up and flip it over, and now you see what the inside of the amp looks like. These are the two RCA inputs, and the input comes down to the volume control, and the output of the volume control goes over to the input tube, which is a 12AU7 tube. This one tube handles both channels. The output from this tube goes up to the 6080 tube, and this is a cathode follower configuration. This is providing the power for the amplifier. And then the output from this tube goes over here to, through these coupling capacitors, and then over to the headphone jack over here. Here's the power supply section. The AC comes in here, goes to the transformer. There's some diodes over here that are the full wave bridge rectifier. And then there's some resistors and filter capacitors to filter the power supply. It all in all took me, I would say, 8 hours maybe to build the amp. I did a little fidgeting around and took photographs and stuff like that, so in the end it took me really about 2.5 days. But if you're an experienced builder, you could build one of these in probably 5 hours. Somebody who's brand new to it, you can expect to spend a couple of days, maybe a week of evenings building it. It was very straightforward. You need some tools to do this. A soldering iron doesn't need to be as fancy as this, but it is nice to have a little soldering station. Need about a 40-watt soldering station, and maybe go between 650 to 700 degrees on the tip. I use 2% silver solder, so I go to 720 degrees on the tip. You'll need a few tools. It's handy to have a little pair of needle nose with a hook on it on the end. Little diagonal cutter here to snip off the leads. You'll need a wire stripper that goes down to 20 gauge, and that's how you strip all the wires to make all the bits and pieces. It helps to have some nut drivers and things like that to be able to screw in the various bits and pieces. A ruler to measure the lengths of wire needed. Just a basic setup for doing electronics. Some solder and some solder wick, which is this stuff in case you make a mistake. I did, and had to change a few things. Anyway, I thought I'd show you some of the techniques for soldering, and so this video is going to be a little bit long because it's we'll show you clearly how to do the soldering and desoldering and various things that are needed to build this amp. But I can tell you it's quite simple, and if you have an idea that you might like to do a DIY project, I would highly recommend the Bottlehead crack. It really is a dandy DIY project. Well, let's do a little soldering. Okay, so I'll show you how to cut and strip a wire. It's pretty straightforward. The wire in this kit is a single solid core conductor, as opposed to having a multi-stranded conductor. It makes it actually a little bit easier to work with. So far, I've found that Doc B's instruction on the wire length has been excellent. Everything's been just a tad too long, but that's good because if you mess up stripping a wire, you can and you cut the conductor, you can probably do it again and still have enough length on the wire. But so far it's been really good experience that way. So I'm supposed to cut a 3.5 inch piece of wire here, and so I get my diagonal cutters and just cut it. Off it goes, zooming over there. So now I have my proper wire, and he says he wants to use 1/4 inch cutoff, which I found to be good. One of the things you'll need is a really good stripping tool. I like this one, and I just got it at a local hardware store, but it's nice and sharp. You don't want to use cutters that are not sharp. This is a 20 gauge wire. It says so on the labeling of the conductor out here, and you want to use the 20 gauge hole to strip it out. Basically what I do is I stick the wire through about 1/4 inch long like that, give it a little push, and that's about it. Do the same thing on the other side. Give it a little push, and then it comes together. And then you just simply take the end and twist it, and off it comes. On stranded wire, I like to make sure I'm twisting in the same direction that the wire is twisted, but it helps make the end nice and neat when you pull the conductor off. On stranded wire, it's really important not to nick the conductors, and on solid core it is as well, because it makes it more prone to breaking right where it gets nicked. Another way a lot of times people will strip wires is to use a knife blade and roll the insulator over the knife blade to make a cut at the length they want it, but that does tend to nick the wire. So using the proper tool is really the way to go if you want your stripping to be nice and clean. Okay, I'm going to show you how to do a typical connection. I need to attach this wire to terminal B2 that already has another wire in it, but nothing is soldered yet. And the first thing to do is to make a little hook shape on the end of the wire. Then you simply insert it into the connection. And then what you want to do is to crimp it a little bit tighter, like this. I'm not sure you can see that very well. I'll try to get it from this side. It's hard to do it this way. There we go. Okay, and then I'm going to put the wire in the direction that it's going to want to go afterwards, like that. And then one of the things to know about soldering is that the solder will flow in the direction of the heat. And heat, of course, is the critical thing in soldering. So what I always do is I put a little blob of solder on the tip, and that's going to help it conduct heat. I put the tip up against the wires being soldered, and then I put the solder in from the other side, and then the solder will flow towards the heat and completely fill the space there. Make sure there's an ample amount of solder without it drooping off, and then let it cool without blowing or moving, and that will prevent it from being a cold solder joint. And it should look nice and shiny over the entire surface of the solder joint. Okay, I have to admit I'm not really much of a fan of using these lower terminal holes, but that's what we got to work with. And what I'm going to do here again is put a dab of solder on the end to use it as a conductor of heat. You can only get to one side of this, so you can't put the soldering iron on the other side. Give it a second to warm up really well, and then feed solder in, give it a nice good blast, and then let it cool all on its own. As Doc B said in the manual, you really want to let these things cool on their own. There's no need to blow on them to create a cold solder joint, and certainly don't let things move around as it cools. Okay, you certainly want to trim the excess lead off, and I use Exolite diagonal cutters for that. There's both flush cut and regular cut, and This is a flush cut pair, and basically you got to get right in there. The camera's sort of in the way, but we'll see if I can get it in there. You want to get it as close as possible. Everything's moving around. You want to get it as close as possible so that you don't leave any opportunity for things to short out. And I always hang on to the end of it so it doesn't go flying off and land someplace where you don't know where it is and short something else out over here. So it's always important to put your finger on the end of the what's being cut off so it doesn't go flying away or into your eyes. Alright, as you can or you may or may not be able to see because it's so small, what I've done is I've bent the two leads of this capacitor. What I'm going to really try to explain here is that it's important just to go slow and steady. What you don't want to do is end up having to troubleshoot your amp when you're done, because building one is a lot easier than troubleshooting one. Then it's pretty easy to blow something up if you don't get it right. Things like being aware of where the stripe is and which connection the hole has to go in. When I did the diode bridge over here, I did get one backwards, but on double checking I saw that it was in backwards and resoldered it. In this case, terminal, I have to put this capacitor between terminals 14 and 15 with the stripe of the capacitor on terminal 14, which is right here. And as you can see, I have quite a number of wires going into this. Quite a number of wires going into this terminal. There's 3 wires in there. And what I made sure was that there was a good size hole. I spent a little while fidgeting around with these wires to make sure there was a hole right where the connector for the cap was going to go in. And you can see there's my screwdriver can go right through the hole that's there. So I very carefully make sure that this cap and its connector goes through that hole, and similarly on the other side that it goes through its hole. Now I've got quite a lot of stuff in that one join, and I can only get to one side of it, and this is where lots of heat and lots of solder help. Now you don't want to put too much solder on because you don't want it dripping off, but again, you tack some solder on there, get the soldering joint warm. You can see it begin to flow around the connection, and then you feed a good chunk of solder in there. If you can get to the backside, sometimes it's good to feed some in the backside as well. And I hope that ends up being a good joint. Add a little extra just to be sure. Make sure I've not dripped solder anywhere. And that seems to be good. And then I can solder the other connector as well. Come in here. Put some soldering on the soldering iron. Put the soldering iron in there. Wait until I see it start melting around, then feed some in. And there you go. That cap is soldered on. Again, it's worthwhile to take your time and do this right the first time so you don't have a problem when you turn it on. On RCA connectors, one of the difficult parts is actually getting the solder deep down into the hole of the connector. Right here you can see that there's an opening, and it goes fairly deep into the connector, and it's typically can be hard to get the solder all the way down into that hole. You get a little air bubble down there. The other problem that happens is that the insulating material right here can melt, especially on the lower cost connectors. These seem fairly good, but you don't want to get this connector too hot, so it is important to get the solder in fast. So now I'll solder this connector. You first position the conductor that you're trying to connect all the way into the hole. And then what I like to do is to put a little dab again of solder on the end of the soldering iron to conduct heat really well, and then put the soldering iron on the rear of the connector and make sure the wire stays in. Put it on the rear connector, and then it'll get really hot, and then you can put the solder down into the connector like that, and it fills up, and hold it down, being careful not to get your finger too close or it'll overheat. And there you have it, a nicely soldered RCA connector without melting the plastic down here. This is the flux that you see building up there on the connector, and with most solders it's okay just to leave the flux, although there are some fluxes that can be damaging over time and you have to wash them off, but with this particular solder it's fine. Alrighty, I've made a mistake here and have soldered this connection when I shouldn't have, and I'm going to have to add some other things to it. And so now I have to remove the solder that's in there, and I'm going to use what's called solder wick. Here's the container. And it comes in various sizes. I tend to use a relatively thin size, a number 2, for most work. What it is, a little braid of copper with a little bit of flux in it. And what it does is, by capillary action, it sucks the solder once you get it hot enough into it, and removes it from the solder joint. And so what I like to do is, this is a pretty good chunk of solder, so I'm going to leave maybe 1.5 inches or so of it, and also I'm going to keep my fingers far enough back, because it will get hot, and you can burn yourself pretty good by holding the solder wick too close. And then I'm going to press on it firmly, and in a moment you'll see it wicking the solder up, and then as I pull the solder through, it's pulling solder off the joint. And here you can see it's taken off some, but not all of it. And I've got now quite a long stretch of lead and solder that's on the wick, and so I'm going to trim it off, and I'm just going to do that again. And it may take a couple times, but it will get the solder off. Now there's other things, solder suckers and so on, that you can use to do this. But I've always found that solder wick really works extremely well. There, now you can see we've got a hole there that I can now put the solder through. It's still the wire that's on there still remains soldered on, but I've pulled off enough solder to get a hole there so I can put the resistors through. And you can see that in total took about maybe 4 inches of solder wick to get all the solder off. Okay, in the article I've put a link in the reference or the resources section to the color codes on resistors. And it takes a little while to get used to reading them. I learned "Bad boys race our young girls behind victory garden walls." That's black, brown, red, orange, yellow. And our young G, green, B for blue, V for violet, W for white. And basically it's the first 2 numbers, and then the third band will be the number of zeros. So this one is red for 2, so black, brown, red, and then V is going to be a 7, and then the yellow is a 4, so 4 zeros. And so this is a 270 k ohm resistor. I always like to make sure that the resistor is the right value when I put it in, so I always ohm it out. because I might have made a mistake when reading it. And the proper way to ohm these things out is to put the resistor on the table over there, and then you can see the meter, and if I push down on both sides, you can see I got 270.8 K ohms, which is correct. Now the thing not to do is to, especially on high value resistors, is to do it this way with your fingers, because what you'll see is the meter's all jumping around, and boy, I don't know what it's really reading, and it doesn't look like it's a 270 ohm resistor. It looks more like 190 or something. Well, what's happening, of course, is you're reading the resistance of your body in parallel with the resistor, lowering its value. So that's why you got to put it on the table and then ohm it out that way so that you can get a good reading on it. Hi, well, I've finished the Bottlehead crack, and I've been doing some listening tests, comparing it with the Woo Audio WA3. Both these amplifiers are output transformerless, OTL, tube amps. Both use the 6080 tube as their power amp stage. The Woo uses 6922s for its input buffer, and the Bottlehead crack uses a 12AU7 for both channels of its input buffer. What I found on listening was it seemed to me first that they're very close in terms of sound quality. The Bottlehead crack seemed a little tighter and a little more controlled in the bass, but it also seemed a little drier, maybe grainier sounding than the Woo. The Woo was a little looser sounding in the bass, but also a little more lush and smooth. Regardless, both are very good sounding amps, and they were quite close. It was not easy to pick the differences apart between them. So the Bottlehead crack is finished, and I really enjoyed building it, and I very much encourage you, if you haven't done a DIY project and think it may be something of interest, to give it a go, because it's a great little project and a great little sounding amplifier. Get a pair of HD 600s or 650s, or maybe even a pair of HD 800s if you'd like, because it's certainly a worthy amplifier to go along with it, and I think you'll have a really great listening experience and a fun time building it. Alright, well, we'll see you next time.